Hi, today we are going to solve exponential equations. Before we do, I want to go over one of the special properties of logarithms, which reads logarithm base b of b to the n equals n. And the reason why it equals n is because the question of the hour is b to what power is going to give us the argument of b to the n. And in this case, I don't want to tag it up, so logarithm base b of b to the n. And the question is b raised to what power will give us the argument of b to the n, and in this case b to the nth power will give us b to the n. If that's a lot of information, we can just keep our cool and do the following. The base of the logarithm is b, the base of the argument is b. Since the bases are the same, they undo each other, and that will leave us with n. No one's gonna know how you did it, okay? So we're good. So first fun problem, let's go ahead and write it. We have, bear with me, so we have 10 raised to the 5x minus 2 is equal to 348. So we have another exponential equation because we have a variable in the exponent, and the question is, how are we going to solve it? It would be really nice if we can easily fix it so the left and right side are in terms of the same base, but sometimes nice doesn't happen. So we can take the logarithm base, whatever our heart desires. The recommendations are use with whatever your calculator has. You could take logarithm base 10 or logarithm base e. So those are my go-tos. And lucky for us, one of the base of the equation is 10. So why don't we just go ahead take logarithm base 10. Let me go ahead and put my calculator away. Okay. So we have take the logarithm of the left side. Take the logarithm of the right side. And then at this point we have options. We can use the power rule for logarithms to bring the exponent down. Or if we take our time, since the base of the logarithm is 10 and the base of that argument is 10, the bases are the same, so they undo each other, and that will leave us just with the exponent of 5x minus 2. So that was pretty nice. So at this point, let's go ahead isolate our variable terms. To undo the subtraction by 2, let's go ahead add 2 to both sides. And to me, it doesn't really matter if you put the 2 before or after the logarithm. On a personal note, I like to put 2 before the logarithm because for some weird reason, if I put it after with tired eyes, I want to add 348 and 2 to make 350, and that is a big no-no. Okay, so we have 2 plus log 348. To isolate the variable, we'll take our time to get rid of the times 5. We'll divide both sides by 5, and that will give us 2 plus log 348 over 5. As always, we are always looking for the exact answer, and then we want to have a sense of what this gives us. So let me go ahead and take out my calculator. And we have 2 plus log 348 over 5. Remember, because in the numerator we have more than one term, the only way we're gonna divide the sum by 5 is if we wrap it up. So open the numerator, 2 plus log 348. Let's go ahead, close the argument, close the numerator, and then divide it by 5. We are asked to round to 4 decimal places, so that should give us x is about 0.9083. Fantastic. So one problem down, 2 more to go. Let's hop to it. Okay, problem B. Okay, so problem B, we have e raised to the 3x plus 5 is equal to 23.8. And yes, as you notice, we have another exponential equation. So it will be really nice if we can easily fix it so that both the left and right side are written in terms of the same base. But as you can see, this is not going to happen. Left side says base e, right side will never be base e. So if we cannot easily fix it so the left and right side are in terms of the same base, then we have no way around it. We have to just take logarithms of each side. Again, my personal take, I take logs based on what my calculator has, base 10 or base e. And in this case, we have a base e, so why don't we just take logarithm base e, also known as a natural log. So we take the natural log of the left, we take the natural log on the right side. And then my natural reaction says, let's go ahead and use the power rule for logarithms to bring the exponent down. And we could totally do that. But if you keep her cool, remember, what is the base of the natural log? The base of the natural log is e. And what do we have? Same situation as before. Base of the logarithm is e, base of the argument is e. The bases are the same, so they undo each other. And that will leave us with 3x plus 5 is equal to natural log of 23.8. Cool. Take our time, work your magic to isolate the variable term. Inverse operation of addition is subtraction. So we're going to go ahead and subtract 5 from both sides. And that will leave us with 3x is equal to negative 5 plus the natural log of 23.8. For the grand finale, to get rid of the times 3, let's go ahead and divide both sides by 3. And that will give us x equals negative 5 plus natural log of 23.8 over 3. So as always, we are looking for the exact answer, but then in order for us to have a better sense of what this actually represents, we're going to use our calculator to give a decimal approximation. So again, the popular mistake is that students forget to wrap up the numerator, but since the numerator has more than one term, if we don't wrap it up, then we're not actually dividing the sum by 3. So let's open the numerator, negative 5 plus natural log. So let me go ahead and show you the button. Let me show you the button with my fake calculator. Okay. So the natural log is the one that says ln. So plus the natural log of, I forgot because my memory is not so great, plus the natural log of 23.8. We're going to close the argument. We're going to close the numerator and divide that by 3. We take our time, round it to 4 decimal places. That will give us that x is about negative 0.6101. Cool. So on the agenda, we are on track to do 3 problems. That's 2 down, so 1 more to go. So don't worry, we're almost done. Problem C. Okay, this paper is stuck. Just a sec. Okay, so problem C, so we can all go home. That will give us 5 raised to the negative x plus 7 is equal to 9. So then again, the question that I asked myself is this: what kind of equation is this? Linear, quadratic, rational, radical? You know me by now, so yeah. In this case, we have an exponential equation, so I'm crossing my fingers. I'm like, oh, can I easily fix it so the bases are the same? And in this case, unfortunately, we cannot. So when that is the case, then we just take logarithms of both sides. Logarithm of whatever your heart desires. So we can take logarithm base 5, which is a really good recommendation. Logarithm base 9. But I feel more comfortable taking the logarithm base 10 or base e. I'm going to go with base 10. So if we take the logarithm base 10 of both sides, that will give us log of 5 raised to the negative x plus 7 is equal to logarithm of 9. From problem A and B, I'm so used to canceling the base and the base of the logarithm and the base of the argument, but in this case the bases are not the same, so no canceling. We're going to take our time and use the power rule for logarithm. So gentle reminder, logarithm base b of x to the r power. To rewrite it, we're going to bring down the power and multiply it by the leftover logarithm. Okay. Oh, I meant to do it as a thinking area, because we box only our answer. So that's where I'm thinking. Okay, so let's go ahead and use the power rule for logarithms. Let's bring the power down. We have negative x plus 7. Let's go ahead and wrap it up. Times the logarithm of 5 equals, well, whatever we have left. on our paper. Let's go ahead, clear those grouping symbols. So when we clear those grouping symbols, log 5 times negative x is just log 5 times negative x. Log 5 times 7, you got it. It's just log 5 times 7. Let's go ahead, bring down the rest of the equation. We take our time. We only have one variable term, so we want variable terms on one side, non-variable terms on the other. To undo the addition, let's go ahead, subtract. So we're going to go ahead, subtract 7 log 5 from both sides. And that will leave us with negative x log 5 is equal to log 9 minus 7 log 5. For the almost grand finale, to get rid of the times log 5, we're going to go ahead, divide both sides by log 5. But then that will leave us with negative x. So let's go ahead, divide by negative log 5. So after we divide both sides by negative log 5, quotient of two negative numbers will give us a positive number. Quotient of log 5 in itself will give us 1. And that will leave us with the desired variable isolated. So that will leave us with x equals exactly log 9 minus 7 log 5 over negative log 5. Now, depending on how we approach this problem, our expressions may not be exactly the same, but when we punch it into our calculator, we will definitely get the same decimal approximation. So let's go ahead, open the numerator. Give me a sec. Cool. So open the numerator, and that will give us log 9, close the argument, minus 7 log 5, close the argument, close the numerator. And we're going to divide that by negative log 5. And then the calculator gives us about 5.6348. Awesome. Cool. So I think that was our last problem. Thank you.